Hello, my name is Brendan O'Reilly and I'm an English and Humanities teacher at John Faulkner College in Melbourne's North. John Faulkner has 276 students in years 7 to 12 and 71% of students have a language background other than English. The school has an index of community socio-educational advantage value of 951 and 56% of students come from the lowest quartile of socio-educational advantage. The goal of this project is to support these students to improve their literacy through engagement with more challenging tasks in humanities. Low literacy levels are a serious challenge across all year levels at this school. The research question is, if the teacher provides targeted vocabulary instruction with every lesson, scaffolds learning tasks for humanities questions, and institutes regular writing practice, will the literacy level of the class improve measurably? I have chosen my Year 9 Humanities class for this project. Of these 14 students, 10 have a language background other than English. PAT data from the start of 2024 gave a class average reading level of Year 5. The school has not had a library for 6 years, and most students struggle to read more than one paragraph of text. They also find it hard to write more than 1 or 2 sentences when a longer written response is required. There's no data available for students E and J who are otherwise included in the data set. There were challenges with implementing the project, but all were managed successfully. The major change from AT1 was taking out collaborative learning. I've used a constructivist pedagogical framework based on Vygotsky's zone of proximal development in this project. Each strategy works by building on prior knowledge and supporting students to extend their learning to the next level. Regarding literature, Quigley and Coleman support using targeted vocabulary instruction with every lesson to improve literacy, while Ilta, Haddy, and Henrik Harmon and Linnerode emphasise that understanding vocabulary is an essential step to understanding content and improving literacy. Quigley and Coleman say that literacy should be taught in every subject, and the use of graphic organisers and building learning tasks around the meaning and origin of words can improve literacy. Quigley and Coleman, Rosenshine and Marzano argue for breaking down learning into smaller, achievable steps, while Routman supports regular writing practice through daily exercises and class discussion, since discussion reinforces learning and makes it more accessible. Regarding ethics, in this project I considered the implicit permission granted to a teacher to plan and teach a class. I also considered individual sensitivities and vulnerabilities. All the data used has been de-identified prior to use in this presentation and has been stored safely beforehand. The project's teaching goals are consistent with the Victorian curriculum and with normal expectations of a classroom. The data has been gathered through normal class practices such as classwork and assessments. The project began in Term 3 with the World War I unit and continued into Term 4 with geography. Each class included targeted vocab, scaffolded written tasks and writing practice. Data collected included common assessment tasks, purpose-designed tests with curriculum content and student classwork. I followed a pragmatic approach to data collection and analysis. Accordingly, I have adopted practical approaches to investigate learning issues and measure improvements in the classroom context. There were 10 data sources used. The first 2 provided baseline data. I designed a pretest as my initial measure of baseline data. However, as the results were very low, I decided to use the Industrial Revolution catch, which the students had done earlier. For each source, I gathered data on 5 metrics: longer written responses, facts and details, understanding cause and effect, comprehension, and the use of complex vocabulary. I created tables for each of the 10 data sources for each of the 5 metrics. I calculated a class average for every table and then put this data into a scatter plot with a trend line. In this way, I could compare student performance across the 5 metrics from before the start of the project until the end. Here is a list of all the data sources. Here, we'll look at 3 groups of data showing the difference in marks attained for short and long answer responses in 3 data sources. In the first metric, long answers, there is a marked decline. in scores for the first data source. This was for the Industrial Revolution CAT, which I've used for baseline data. This graph shows that the average score declined from 60% to 40% and then to 39% for questions 11, 12 and 13. Question 11 was a closed question, explained 2 ways that transportation improved during the Industrial Revolution. Questions 12 and 13 were much more open-ended. Question 13 asked students to write 2 paragraphs to explain why the Industrial Revolution began in Britain rather than elsewhere. The data from these 3 questions seem to confirm my impression that it is much harder for these students to complete an open-ended writing task than to answer a closed question. The drop-off is even more marked in data source 2, the pretest. The average class mark for shorter responses is 30%, and it falls to 12% for longer responses. However, in the last assessment, student performance in longer written answers was higher, 52%. And for shorter answers, 51%. Scores for the longer answers are now 1.25 times higher than for source 1, and more than 4 times higher than in source 2. I'll be looking at this again later in this presentation when considering effect sizes with Hedges G. Here are the basic plots of the entire data set for long answers. The y-axis measure the average percentage score for the class for each of the 10 data sources across the life of the project. The x-axis has the sources in chronological order. Note that there are only 6 data points on the short answer chart but 10 on the long answer chart. This is because short answers were not actually one of the metrics of this project and only 6 sources were available. I noticed that there was a possible outlier on the long answers for source 2, the pretest. These low scores were evident on the previous slides. To investigate this, I used the inner quartile range method to calculate an upper and lower bound or fence and found this data point was a mathematical outlier. These are the same plots with the outlier removed. Here are the trend lines for the short and long responses with the outlier removed. You'll see that the trend line for long responses is less steep than that for short answers, suggesting that students are improving more at short answers than long. But for now, I'm going to leave the outlier in and combine the plots to compare the trend lines. Now that we've included the outlier, the long answer trend line appears to be steeper, showing greater improvement in the longer responses. This is not surprising since there are more marks to get in long answers and students were coming off a low base. I'm including the outlier because this was from a specially designed pretest and it was an authentic measure of student ability. I've looked closely at the data source and there were no inherent flaws. Alexander Street and Grace Martin support the inclusion of outliers in data sets unless there are obvious flaws in the data. In any case, small sample sizes such as this one are likely to produce outliers. While accepting the limitations of the data, I note the greater improvement in long answer responses. Appleby and Langer show that longer written responses demonstrate higher level literacy skills, while the research of Carenti and others found a correlation between how students respond to texts and how they are taught to reason and to write extended responses to questions. It should follow that writing an extended response that demonstrates comprehension and analysis is an indication of higher literacy. This graph measures student responses to questions where they need to recall facts and details. It shows a gradual improvement from 60 to 70% across the project. This graph measures student understanding of cause and effect and shows an increase in the average class mark from 39 to 60%. Again, with comprehension, there is an observable improvement from around 55 to 65% for the average class mark. Complex vocabulary has improved in this graph from around 30% to 45% for the class average. Along with metric 1, long answers, this data provides an interesting result when used to calculate Hedges G, as we shall see in the following slides. I've calculated Hedges G for each of the 5 metrics by comparing data from sources 1 and 2 with source 10. Hedges G is designed for use with small sample sizes and is suited for this project with its small class size. Note that there are 14 students in the entire data set and 12 of these sat assessment 1. Therefore, the figure 12 is used in the Hedges G calculation. Hedges G uses a weighted and pooled standard deviation, which takes into account potentially different dataset sizes. Here is the formula for Hedges G with the calculation for metric 1 long answers comparing sources 1 and 2. First, we calculate the pooled weighted standard deviation, which is 23.2194. We use this to calculate Cohen's D, which is 0.23687. We now use Cohen's D to work out Hedges G, which is 0.21382, which we can round up to 0.214. Note that this calculation actually gives a negative value for Hedges G because calculation of Cohen's D requires a subtraction of the mean of the second data set from the mean of the first. If the second mean is higher than the first, and in these 5 cases it is higher, then the Cohen's D value will be negative. In this instance, the negative value indicates an improvement rather than a decline. For metric 1, there is a Hedges G value of 0.214 between sources 1 and 10. This is a small effect size, but it is possible that this would be greater if the project continued for more than 10 weeks. When comparing source 2, the pretest, with source 10, the G value is 1.012. Since a G value of more than 1 is a large effect size, this is surprising and perhaps unlikely in a short-term project such as this. Nonetheless, it is what the data tells us. This underlies the low baseline established in the pretest, data source 2, and this is why I've included data source 1, the Industrial Revolution CAT, for a second and possibly more accurate baseline. Given that an effect size of 1 is large, the effect sizes of the middle 3 metrics appear to be so large as to be flawed in some way. For instance, metric 2, measuring facts and details, has effect sizes of 6.682 and 6.545. This is due to several zero scores in the first 2 data sources, which will have skewed the data. These large effect sizes are seen again in metrics 3 and in metric 4. In metric 5, which measures vocabulary, there are much lower G values of 0.259 and 0.631. These are small to intermediate effect sizes. We should probably discount the Hedges G value for the middle 3 metrics. A close look at the data sets shows a number of 0 and very low scores in the first assessments, and these have skewed the data. However, the G value for metric 1, long answers, and 5, vocabulary are worth considering. They indicate that the data shows a measurable improvement in these metrics across the life of the project. This reinforces the impression I conveyed earlier in this presentation that students were showing marked improvement in writing long answers to questions. In summary, the data shows a measurable improvement for each of the 5 metrics across the life of the project. This was most pronounced for metric 5, long answers, and this was a significant result as the literature supports long written responses as a key measure of literacy. My own observations were that students seemed to be more engaged in their work at the end of the project than at the beginning, but there were also factors outside of the project that may have contributed to this. Even so, the project has appeared to be successful using the data I have gathered and presented here. Of course, we still need to treat the data with caution. Correlation does not equal causation. The data set was small, the project ran for only 10 weeks, and in such a short time, factors outside of the project could have a significant impact. For instance, the engagement and behaviour of one student improved noticeably over the life of the project, and this had an observable and very positive impact on the entire class. We also need to consider the possibility of researcher bias. I teach these students every day and I'm invested in their learning. I can't pretend to be an objective outside observer who sees and records all available data, whether it supports my teaching goals or not. Regardless of the findings of this project, the need for improved literacy at this school and in this classroom is very clear, given the data with which I began this presentation. As a humanities teacher, I'll continue to emphasise literacy skills in classes so that I am teaching essential skills alongside curriculum content. I will do all I can to nurture a love of reading and writing among my students, and I'll work for John Faulkner College to have what no school should ever be without, a fully staffed, well-equipped school library.